Friends, welcome again into yet another session of Maths into my YouTube channel, Maths with Mukesh Raj. Today, we will be starting with a new chapter, Trigonometry, and its different uses into our day-to-day life. Trigonometry is one of the important topics which is supposed to be studied from the point of view of class 10th. And friends, as we know that the trigonometry, and without wasting time, let us start the trigonometry. And today we will be starting our discussion with the trigonometric ratios and a brief introduction of what trigonometry exactly means to us and how can we implement it. First and foremost things, friends, the trigonometry is all about dealing and measuring the units associated with a triangle. Trigonometry literally means that the measurement, or it's the branch of mathematics, or we can even call it as a science of measurement of triangles. The name itself describe in brief, and we would see it that how it is being associated. Dear friends, before we start and look onto the content and the topics in detail, it's my humble request that please do not forget to like, share, and subscribe my channel, Maths with Mukesh Raj, where we are studying and trying to make mathematics learn and study it in an easier way with concepts. Friends, trigonometry, the literal meaning of trigonometry means that it's going to be the science that is used or deals with the measurement of the triangles. And if we do the anatomy of this word trigonometry, this trigonometry can be divided into three different parts, or the anatomy gives us three different independent words which belongs to the Greek terminologies, where tri means three, gon, as we have already seen, polygons, and in different geometric shapes, that gon basically means the sides, and metron is associated, a Greek term that is associated with the measurement of any quantity or any of the units that we are looking for. And this trigonometry, as it is describes itself, that it's associated with the measurement of the units, measurement of the parts associated to a triangle. But one important thing that I would like to add in addition to this is that it's associated with the right angled triangle. So we should always keep into mind one thing, that while dealing with trigonometry, somehow or the other, we are trying to associate all the measurements in terms of a right angled triangle. And see, this right angle triangle has got certain things that we should be aware of. A right angle triangle is always having a 90 degree at one of its side, as one of its angle as equal to 90 degree, and then the rest of the two angles will always be less than 90 degree. That means the other two the angles of the triangle, of a right angle triangle, will be acute in nature. And few terminologies that we should be aware of. See, the terminology, the line that becomes the base of the triangle is known as the base. This is the line segment, this is the side called the base, or it can also be called as adjacent if we are talking about the angle C. And this one, the line which makes the angle 90 degree onto the base, is known as perpendicular. Just a bit. It's known as base, denoted as base B. It can be denoted as base as B, and perpendicular is denoted by perpendicular small p. And the longest side of this right angle triangle is known as hypotenuse, which comes from the Pythagoras theorem that we have already seen into our previous classes. Now, how this trigonometry helps us in finding out the measurements. This trigonometry helps us by the help of trigonometric ratios. Okay, these are the comparison of the different sides of this right angle triangle that will help us to find out any particular angle. That is why it's known as the trigonometric ratios. In general, these trigonometric ratios are made familiar with a general term known as the angular value called theta. All the measurements will be considered or taken into account with respect to a general angular value called theta. But theta is nothing but this is the angular measurement of either of the two acute angles that are present into a right angled triangle. Moving ahead, I would just try to make you familiar with this ratios. First of all, let us understand for any right angle triangle, for as I have drawn a right angle triangle onto the right hand side of the screen where you can see this triangle very clearly. So taking into reference the same triangle, I would like to explain the trigonometric ratios one by one with respect to the opposite, perpendicular and the base. And this base is also known as, sometimes it's also known as the adjacent. Why it is called adjacent, I will just explain it to you. Suppose that we are having an angular value, say I am going to find out the measurement with respect to angle A. So in this respect, since this is the angle for which we are trying to find out the measurements of different sides of the triangle, so I'm marking it as an angle theta. So in this case, the side which is corresponding, which is immediately corresponding to that of the angle, becomes the adjacent side, or it is known as adjacent side. And the side which lies just opposite to that of the angle becomes the opposite side. So this is the basic terminology that we should be known before we start or analyzing these trigonometric ratios. For the angular value of theta at angle A for a given triangle ABC, where angle B is having a right angle, then we can associate it with the trigonometric ratio of sine value for A, or instead of this sine value of A, even we can write here sine theta. So both works perfectly all right. So sine theta will be equal to that of opposite side to that of the hypotenuse. Which is the opposite side? Here this opposite side is BC. I will write it first as opposite side and then the hypotenuse, that is hypotenuse, and correspondingly the length. Here this opposite and hypotenuse means that we are talking about the length in any of the given units. It can be centimeters, millimeters, meters, or whatever the convenient uh, parameters for measuring the lengths are supposed to be taken into account. So this opposite will be used for BC and then I will be using it for AC. This is the how the trigonometric ratios are being taken into consideration with respect to a right angle triangle whose right angle is formed at angle B, and we are trying to find out the ratios with respect to the angle theta corresponding to the apex angle A. Now let us see the different all the other trigonometric ratios in accordance with the given triangle. Similarly, we are having cos of angle A. Again, we can write the same thing correspondingly as cos of theta. that is cos of angular value theta. It will be again opposite side by adjacent side by the hypotenuse. So adjacent side here means adjacent to the angle for which we are trying to find out the value, and then the hypotenuse. Again, the adjacent is nothing but it is the AB and then AC upon AC. Similarly, we are having the tan value of the angle. Then again, we are having cosec value for the same angular value. Then again, cosec value for the sec value for the same angular value A. And finally, we are having this cot A. So these are the 6 basic trigonometric ratios that we are supposed to be aware in order to find out the lengths, or in order to measure the lengths of the corresponding sides of any given right angled triangle. Hope, dear friends, this much might be clear to you. And proceeding further with the next discussion, that how these trigonometric ratios are associated or related to different types of relationship. The first relationship is known as the reciprocal relationship. The first of its kind of relationship is the reciprocal relationship. The reciprocal relationship says that each and every basic out of these 6, these 3 are the primary or basic trigonometric ratios, and out of these basic or primary trigonometric ratios we can find out the other 3 given trigonometric ratios, that is sec, cosec and cot. So let's see how these reciprocal ratios are related to each other. As it's visible from the screen, on the screen, that the reciprocal ratio says that cosec of any angle in a trigonometric ratio, that means the acute angles, is associated as the inverse of sine value for the same angle. Similarly, sec is the inverse of the cos value for the same angle, whereas cot is the inverse of the tan for the same angular value. So the formula that comes out to be here is, it becomes cosec theta will be equal to 1 upon sine theta, and in an opposite way we can write the same formula as this. Similarly, here we can write the same, can be written as sine theta will be equal to 1 upon cosec theta, and in the same way the cos theta will also become will be 1 upon sec theta. And then similarly we can use the same type of methodology in an inverse way, in a reverse order, that the tan of theta will be equal to 1 upon cot of theta. So this is how the reciprocal relationship works on. Let us see the next relationship, that is known as the power quotient relationship. This is the quotient relationship, where we are trying to find out the quotient relationship for the given trigonometric ratios. The trigonometric ratios, as I told you, there are basically 3 basic trigonometric ratios, that is sine, cos and tan, and rest of them are derived, that is tan, cos and cot. These 3 are the ratios which have been derived from sine, cos and tan. Listen friends, the quotient means that how the cot and tan are related to each other. The tan theta is nothing but it is the sine theta, ratio of the sine theta to that of the cos theta, and then the cot theta becomes the reverse. As we know that tan and cot are reverse to each other, inverse of each other, therefore the tan theta, if it becomes sine theta upon cos theta, then the cot theta will be represented as cos theta upon sine theta. That means the reverse of the quotient relationship for the tan value. And finally, the product of tan and cot will always give you a fixed quantity. It's always a constant termed to be 1. So these are the relationship between the different trigonometric ratios for our reference so that we can solve different kinds of problems. The power. In order to understand the concept of trigonometry and trigonometric ratios in a proper way, we should understand the concept of power of the trigonometric ratios. Power of trigonometric ratios means it's similar to that of the general power that we are using for any variable in an algebra or in an algebraic expression. Suppose that we are having any algebraic expression. Let's suppose we are having an algebraic expression a raised to the power 2. For this a square term, what we can say that in an expanded form, we can write like this: a multiplied by a. That means it will be multiplied for that many number of times. Similarly, a sine square, any of the trigonometric ratios, if the square of that trigonometric ratios are taken, that means that square term will be associated with the sine, not with the theta. That means angle will not be multiplied, angular value is not going to be multiplied. That square term will be associated with the trigonometric ratios and not with the angular values. Similarly, the same thing can be written as if we are having like power of 3, 4, in the same way it could be represented. Suppose instead of 3 we are having 3 here, 2 here, then again this will be associated with the sign of that particular power. Friends, hope these concepts of trigonometric ratios and relationship will definitely help you to solve your problem and score good into your forthcoming exams of the board. And once again, I would like to request to one and all the friends who are watching this video right now, thank you for watching. And if this video gives you value and if you find it worthy for yourself, then please do not forget to share with your friends and family, because that sharing, that single comment and that subscription motivates me and gives me that enthusiasm and energy to come up with new and interesting videos so that they may be useful for your studies. Thank you, friends. See you in the next video with the problems of the topics that we have discussed so far. Thank you very much, friend.